collection of data. It's usually stored electronically on a desktop or a server. And databases can hold all sorts of data. So they can hold weather data if you're tracking daily temperature highs and lows, medical data if you're working in healthcare, so things like patient blood pressure or blood pressure changes over time. It might hold business data such as invoice numbers or sales records. If you can think of a type of data, you can put it in a database. And the reason I included these pictures here is that you can think of the library in a sense as a sort of database. It stores data or books. You have ways of looking up your data easily. So you might remember from back in the good old days, instead of having a nice slick computer interface for looking for books, you had these index cards that track the records of what was in the library and when it was checked out and all of that. So that's the basics of what a database is. Now, in order to interact with databases, you might use something called a database management system, or DBMS. A database management system is a software system that allows users to interact with their databases. With this software, you can typically perform 4 major types of operations, which people usually refer to as the CRUD operations. So you can create data, which is the C in CRUD. So let's say that you are running a website that people are signing up for. When somebody signs up for your website, you'll want to create a new record for that user. So that's the create command. You'll want to read data, which is the R. So users can read from existing data in the database. If you wanted to check who your website's current users are, for example, you could do a read operation to check that out. The U in CRUD stands for update. So users can update or change existing data in the database. For example, a user signed up for your website, but they've changed their email address. You don't want to get rid of the user. You don't want to create a new user. You just want to update some of the attributes attached to the existing user. So that's where the update command comes in. And finally, you have the D, or the delete commands, which means that users can delete data in the database. So let's say that you've signed up for this new website, you've used it for a while, but now you don't want to use it anymore and you want to delete all of your data off the website. Then you'd execute a delete command against the database and make sure that you got rid of all your data. So a database management system is what enables you to do that easily. And there are lots of different database management systems out there, such as SQLite, Oracle, Microsoft SQL Server, MySQL, PostgreSQL, all sorts of stuff. Those typically fall into what are called relational database management systems, or RDBMS, which means that the tables in the database are related to each other in some ways. There are also what are called NoSQL database management systems, which we will not talk about in this class. And that's more for unstructured data, such as documents and that sort of thing. So within your database, you'll have things called schema. So what is a schema? A schema is something that defines the structures and rules inside of your database. Your schema is sort of like the blueprint of your house. You're not going to live in it, but it helps you see at a high level what your house looks like. Schemas define things like who has access to the data, what they can do, how the data is stored, and a lot of other things. Finally, at the next to most basic level of the database, you'll have what's called a table. So if you've seen a spreadsheet before, like something like Microsoft Excel is pretty common, then you've seen a table. All a table really is a structure that contains data across rows and columns. Columns are sometimes called fields when you're talking about databases. And tables are really one of the most fundamental and useful of all database structures. And that's what we'll spend most of tonight working with. Finally, you might ask yourself, if you're taking an Introduction to SQL class, what is SQL? SQL stands for Structured Query Language. It's a standardized programming language that's used for interacting with databases. SQL is what allows users to perform the standard CRUD operations that we talked about earlier. And technically, SQL is not so much a language as it is a standard for languages. So tonight, for example, although we're learning SQL, we'll be learning the PostgreSQL dialect or variant of SQL. And there are many other variants, such as I mentioned before, SQLite is one, Microsoft SQL Server is one, MySQL is another. They all have the same basic CRUD functionality, but they might have different functions and different, slightly different syntax. So with that, I'll exit out of this presentation since we've seen all that we need to see there for now. And we can go into our coding session. So in order to set things up, I will post the wiki in the chat, but you should go to the wiki. Let's find the chat. Post this for panelists and attendees. So that's the wiki page for this course. So to get started, you can open up SQL Fiddle, which is where we'll be coding, in a new window. I already have it open here. And you can open this link in a new window as well. And all this is the raw data for this course. So what you can do is you can just do a Control A if you're on Windows, or Command A if you're on a Mac, to copy all this data. Once in here, you can go to SQL Fiddle, go up to the top, change this to PostgreSQL 9.6. So you can see there's a few different dialects that we could try out, but we're going to be doing PostgreSQL tonight. And then in this left panel here, you can Control V or Command V to paste this data in, and then you can do a build schema. And so what we've done there is we've populated our database with some sample bit data that we can use for the course tonight. And I'll just check that everything is there that I expect to be there. And we've got data in there. So we're good to go. So if you run into any issues in terms of populating data, please post to the Q&A or post in the chat, and we'll see if we can get that figured out. So if anybody has any questions at this time, feel free to post them in the Q&A, and we can try to answer them. But if not, we'll move on and we'll jump into working with our data. So in order to start working with databases and the data within the database tables, you'll need to be familiar with a fair amount of SQL and various SQL clauses and keywords. So we're going to walk through what they are and how they work as we go through the course tonight. And also, if you'd like to see a visual representation of the data that we're working with, you can go to the wiki here. You've got a picture, or you can open up the database diagram and see it here as well. So to start with, we'll start with the select keyword, which is what you see there. Now, the select keyword for us tonight will be the most important SQL keyword that we use. It's really the heart and soul of almost any SQL query that you write, especially if you're doing mostly reporting or data analysis. and not as much database administration and those sorts of tasks. Coming along for the ride with the select keyword is this asterisk or star character here. All this means, this is just shorthand for all columns on the table. So you can use it if you don't want to bother typing out all the fields or column names that you want to pull from a particular table. So instead of writing, for example, here, select ID, first name, last name, ... I can just replace all of that with a select star. So if the select is telling us what we want to pull out, the from keyword is what tells us where we want to pull it from. So if you're interested in the customer data, for example, you want to pull from the customer's table. If you're looking at medical data, you might want to pull from a surgeries table or a visits table or a patients table. All it does is identify the table that you want to pull data from. So if I want to look at the orders that we've got in our sample data, I could do select star from orders, run that, and this will give us some order data. Now that we've got our select and our from, you can start analyzing the data a bit more. So one of the things we might be interested in is looking at the unique or distinct values for a particular field in a particular table. We can do that with the distinct keyword using select distinct. So let's say that I want to know what paintings I've sold in this sample data set. I can do select distinct painting name from orders, and this will give me all the unique painting names from that table. So you can see we've got, let's see, 6 different paintings that have been sold. So if you're running this shop and you want to know which paintings people are buying, you might find out, hey, they're buying some of these ones, but not some other ones that I've painted. SQL also allows you to do what's called aliasing, or renaming fields and tables to whatever name you want to call them in your select statement. Usually you'll do this to prevent field name conflicts. So if you're merging 2 different sets of data together and they both have a field name of ID, you might want to rename it so that it's clear which ID field you're referring to. You can also change it for legibility, and this is most often seen if you're writing a report and you want your field name to be something that's human readable, essentially. So here we'll use the as keyword to rename this to painting name. And now you'll see, instead of having this all lowercase underscore, we've got a slightly nicer name with a space in it. So now you've looked at some of the unique features of your data. You've renamed your the fields in your database to report on them or do what you will. As you're looking around your data, you might not want to return everything all at once. So for example, if you have some database tables with millions or billions of rows, you might not be interested in all the little tiny things. You might just be interested in some sort of sample of the data. And this is where the limit clause comes in. So the limit clause probably does what you expect it to do. It limits the returned set of items from your query. So here, for example, if I wanted to limit to just 5 painting names, I could run this with limit 5. And then we should see the last one drop off. So now we've just got 1, 2, 3, 4, 5. And then after that, everything gets dropped. Or let's say you've got some big table somewhere. So let's say we'll take a look at our customers table. And you just want to see the first 10 customers. You can do that, and then you've just got 1, 2, 3, all the way through 10 to take a look at that. So again, it's useful if you want to batch your data, if you just want to get a subsample of data to look at. Next, we'll take a look at the order by clause. The order by clause allows you to sort data in ascending or descending order across one or more columns. So if you have experience, again, with Microsoft Excel, this is pretty similar to the sort and filter functionality that exists with Microsoft Excel. So let's say you want to look at a list of customers in alphabetical order. We could write the following query. So we'll say we just want their first name and last name. So we'll say last name, first name from customers. We don't want a limit on it, but we do want to order by the last name. And we'll go A to Z as opposed to C to A. So if I run this, you'll see we start at A and we'll end somewhere near Z. In this case, W, because that's what's in the sample data. You can flip it around if you wanted to go Z to W. And then it just puts the last thing at the top. This works for text fields as well as numbers fields too. So if you wanted to see the largest orders for each customer, for example, you could chain different order bys together. So we'll do select, let's see, select customer ID, painting name, order amount from the orders table. We'll order by customer ID ascending, so it'll go 1, 2, 3, and then order amount descending. So it'll be a descending sort on the dollar value of the order. And then we'll limit it to, let's say, 25. So if we run that, then you can see we've got first we sort by customer ID, then by the order amount. So this is going, the most expensive painting they bought was this first one, $833, all the way down to $238. And then it starts again for the other painting names, or the other customers rather. Are there any questions so far for selecting or sorting data? If there are, please post them to the Q&A and I will take a look at them. Okay, from the questions, schema ready. Yeah, okay, yeah, just hit the run SQL on the side and that should resolve that issue. Q&A. Okay, what did the asterisk stand for again? So that is the asterisk stands for all columns. So if I wanted everything from the orders table here, I could put that in, and that'll get me all of the fields. So not only do I have the customer ID, the painting name, and the order amount, I also have the ID and the order date of all of these as well. So it's just a shorthand so that you don't have to type out ID, painting name, customer ID, ... because there's no telling how large your tables can be. They can really have, hundreds of columns sometimes. And if that's the case, you don't want to have to type that all out. So thank you for your question, Susan. I think it was who asked that. Yeah, Susan. So thank you for the question, Susan. That's what the asterisk stands for. So good question. Moving on, now that we've selected data and we've sorted our data, we'll start filtering through our data. So this is where SQL starts to get really powerful when you want to start looking at subsets of your data, because really that's how a lot of data analysis in the real world works, right? So you're running some sort of medical study and it's in patients over the age of 65. So you want to analyze your data and exclude patients under the age of 65. Or maybe you want to see what your major orders are. And so you want to filter down to just orders over $100. Or you're looking at temperature and you want to select days where the temperature was below freezing, which based on the weather report sounds like it's going to be tomorrow in this area. So all of those are examples of filtering tables in your database. And the clause that we need to filter data down is the where clause. So what the where clause is looking for is essentially one or more logical conditions that it can filter rows by. So if we're looking at our orders table, maybe we just want to look at orders over $100. So we'll start our where clause. So select star from orders where order amount, which like you can see here is the dollar value on the order, where order amount is greater than 100. If I run that, this gives me some subset of the data, but everything in here will have an order amount greater than $100. So like I said, there's a whole bunch of ways that you can filter data depending on what your data looks like. So maybe here we want to see all the orders for a specific painting name. So we could say where painting name is American Gothic. Filter on that. And now you've got some subset of the data related to those paintings. So right now we've just got one logical statement. Painting name equals American Gothic. But maybe there are multiple conditions that we're interested in. So where painting name is American Gothic, and the painting was ordered in the year of 2019, something like that. So that's where the and keyword comes in. So the and keyword lets us combine these logical conditions together in a normal way. So here I'll say, or we can filter on order amount actually. We'd say order amount greater than $100. So if I run that, we should see a couple, our set of data is a little bit smaller. So there are some orders with an order amount of less than $100 in there. So that's how you can combine things with the and clause. And again, in order for that to be returned in this set, both of these conditions have to be true. That's what the and is doing. It looks like we have that. So in the Q&A, why is it sometimes next to the action and sometimes below? I'm not quite sure what this question means. So if you can maybe rephrase it a little bit and put it back in the Q&A, I'll try to answer it in a couple minutes. But thank you for the question. So next up, similar to the and keyword, is the OR keyword. The OR keyword is another way of filtering by multiple logical conditions. But unlike with the AND keyword, only one of the logical conditions combined with an OR keyword has to be true in order for the entire where clause to evaluate to true. So let's say that we're interested in seeing which one of our customers maybe comes from the DC area. So we'll look at customers, and the field names we're interested in is state. So we'll say where state equals Virginia, or state equals Maryland. And I'll leave DC off because I can't remember if it's, here we go, District of Columbia. Or state equals District of Columbia. So if we run that, then we'll just get these 3 people who live in those 3 states. So again, for this to evaluate to true, any one of these statements could be true. So they could live in Virginia, in Maryland, or in DC. And okay, let's see. Okay, so some questions. SQL doesn't like double quotation marks. Is everything based on single quote marks? That's a good question. It depends a little bit on the dialect. So I think this might be true for Postgres. So let's try that. Yeah, so for Postgres, for text, you'll want single quotes. Although I think you can use, so let's see, first name as first name. You can use double quotes for renaming. So I run this. Yeah, so it's a little bit of a, the answer to that one is a little bit of, it depends on what you're doing. So it seems like here, if you're comparing text values in your query, you'll need single quotes, but you can rename your columns with double quotes. And let's see if this works with single quotes too. Yeah, so here, for example, you need double quotes for column alias, but single quotes for any sort of calculation. So John, I hope that answered your question. So let's see. Okay, so, okay, I see what this question is. So this is a formatting question. So the question is really, how do you format your queries, and does it matter? To a certain extent, it doesn't matter. White space is not important in how SQL queries are evaluated. It becomes much more of either personal preference or organizational preference if you're working at a company that uses SQL. So for example, at my work, there's a style guide on how you write SQL, and it would ask you to do this if you were writing code to go into production, where you have things on all the conditions on separate lines. For the course tonight, it's fine to leave things on the same line if there's not really, if you're not really doing anything with it, if you're just, poking around at your data. So like I said, it's a little bit personal preference and just making sure that it's easy to read. So if you had 4 or 5 of these, you might want to separate them out onto separate lines just to make it easier for other people to read. But that's a good question because style can be important when you start writing more complex SQL queries. So we've used the or keyword. We're looking for people with who live in the DMV area. But what you probably notice is that this is a little bit tedious. We've written state equals Virginia, state equals Maryland, state equals District of Columbia. And this is fine for looking at 3 states, but what if we wanted to look at 10 states? Or what if you were analyzing healthcare data where somebody might have dozens of diagnoses and you're interested in a lot of them? This is where the in keyword comes into play. So what the in keyword lets us do is evaluate against a list of values. So instead of making combining things with the or keyword, I can just do this. So we'll type out Maryland and then District of Columbia. I do this. Let's say we'll do this back to select start so that we're getting everything, not just the first name. You'll see we've gotten the same result as we had before. We've got all the people living in the DMV area. So as you can probably tell, what this statement evaluates is whether somebody's value for state is any one of these values in the list. So this is a lot cleaner to write, and it's a lot easier to read than combining things with multiple or statements. In your database, you'll sometimes have text data. And like we can see here, there's lots of text data that we might be interested in. So we've used some equal signs, some greater than, some less than. We've used the in keyword. There's another keyword called like. The like keyword is used for case-sensitive pattern matching with strings or text fields. So you can use the like keyword to search text fields for words that contain specific characters or words. So the 2 special characters that we'll be interested in using with the like clause are the percentage sign and the underscore. And we'll see how those are used in a minute. So the percentage sign matches 0 or more occurrences of any given character. And the underscore matches a single occurrence of any given character. So these characters are sometimes called wildcards since they can be anything. So what we're going to do is we'll look in our customers table for anybody whose, let's see, first name is like BE percentage sign. And what this is looking for is any name that starts with B and then has anything after it, or starts with BE and has anything after it. So if I run this, let's see. Interesting. There we go. I was wondering why that was happening. OK, so this filtered through our table and looked at first names that started with BE. And you can see we've only got one in there, and that's Betsy. So if there was a Ben or a Benji, we'd catch that with the BE percentage sign. So maybe we want to be a little bit more clever. And maybe we'll say we want to look at people whose first name starts with any letter, then has EN, and then a percentage sign. So there has to be a letter there. That's what the underscore is. And then anything can come after the N. So if I run this, Run it again. Oh, and that's what it is. So when I run this query, I get one person being returned from the query. So we've got Xena. So the Z matches the underscore, and then the A matches the anything that comes after the N. So that's why we get Xena coming through in our query here. As a side note on some of the differences among SQL dialects, is that PostgreSQL, which we're using right now, has the I-like syntax. So if we did this, ran this, I-like is a case-insensitive search. This keyword is only available in Postgres, I think. For example, I work with MySQL right now in my work, and MySQL does not have a case-insensitive like search for strings. You have to use other methods to handle that. So that's just a little fun fact of differences among the SQL dialects. Now, let's say that you're interested. We filtered on some strings. We filtered on some comparisons and through lists. But let's say you're interested in filtering data that's within a range of values. And most usually you see this in ranges of ages, or maybe ranges of dates, or a range of monetary values. So instead of writing a long list to use with the in keyword, so let's say you wanted to find patients between 18 and 35, you don't want to say patients where age in 18, 19, 20, so on and so forth. You can use the between keyword to specify the start and end of the range that you're interested in. So if we go to the orders table, maybe we're interested in orders placed between the beginning and end of June. So from orders, where the order date is between, and this is older data. So we'll say 2019-06-01 and 2019-06-30. And so this will capture all the orders in the month of June. So if I run that, it'll return these 4 paintings. So these are all the paintings that I sold in the month of June. Or if you, again, if you wanted to filter on orders, let's say, we'll say order amount between, let's say, 35, or maybe let's say 100 and 500. If I ran that, it will return some amounts of paintings, all of which are between $100 and $500. Finally, the last keyword that we'll learn about in terms of filtering data is the not keyword. The not keyword is a logical operator that inverts the conditions that you apply it to. So this is useful if your exclusion criteria, the things that you don't want, is smaller than your list of inclusion criteria, the things that you do want. So for example, to go back to our earlier example of customers in the DMV region, we could say Virginia, Maryland, District of Columbia. And this gets us everybody from those states. Maybe I want to see the people who aren't in the immediate area. I can just say where state not in, and run that. And now this gets me the people from everywhere else.
Ben, you have a question in the Q&A going back to the date.
Gotcha. Okay, so let's see. Is the date format native to SQL, or was it specified in our sample schema? So that's a good question. Various SQL dialects have various ways of storing this. So I believe here, here we've stored it as a date type natively. So you can work with it as a date. We've chosen to store it that way. You can store it as a string or as text, but you lose out on some basic functionality. That said, there's a number of different date and time types that you can use for storing data. So you've got date, you've got time if you want to store, hours, minutes, seconds. And then you've also got what tends to be used more often is date time, which is both as its name implies, the date and the time. So that would be, for example, 2018, 12/27, and then 1700 and 43 minutes or whatever the time is. So how you store your date or date time data is dependent on what you're using it for. Yeah, I think that I hope that answers that question. But there's most SQL dialects have a native date format, but you do need to specify it when you set up your database. But good question. And if you have questions in terms of how your particular dialect works, it's always useful to go to your documentation. So this is the documentation for the version of Postgres that we're using right now. It's a few behind what you could get on your own machine, but again, that's because we're doing it in a web browser. So if I go to data types, we can look at, let's see, date and time types. And so you can see here you've got timestamps without time zones, dates, times, and intervals as ways of storing data. Yeah, so hopefully that answers your question. Great, okay, awesome, it does. Thanks for the feedback. Great, okay, so far we've learned how to select data using the select from clauses. We've learned how to filter data using the where clauses. What we're going to move on to is aggregating data. Aggregating data is another place where SQL really shines and where it tends to get and a reason it tends to get used a lot. So SQL is very good for aggregating or grouping data for various sorts of calculations. So selecting and filtering data might get us the data that we need, that set of data that we need, but it may not help us understand some of the broader questions that we may have. So that's where SQL's aggregate functions, such as the max function or the sum function, come in. These functions can be used over entire data sets. For example, if we wanted to know the average dollar amount of all the orders that we've had, or within subgroups of data, which is where the group by clause comes in. So for example, if you wanted to know what the dollar value of orders by month was. So we'll go over to our orders table since we're interested in that. And we want to know, well, what was the total amount of sales that I had over everything as total order amount. So we're selecting, we're aliasing, and then we're doing a sum on the order amount. And you'll see the total order amount in that table is looks like $25,280. So we're summing the orders over the entire table. Um, there's a lot of other functions, such as the count function, which essentially counts the number of rows in a table. So we'll go to our customers table and we'll select count ID from customers as number of customers, and that will count the number of customers that we have. So we'll go there. We see we've got 40 people in the customers table. If you're just interested in the number of rows in a particular table, you can go back to our star character and just do a select count star from the table that you're interested in. So if we run that, we'll get 40 again. And if we go to orders, we'll get, there's 50 orders. So again, count star is a nice shorthand for things. As I mentioned before, right now we're doing these aggregates over the entire table, but we might be interested in some sort of subset or grouping it by some feature of the data, and that's where the group by clause comes in. It allows users to specify the groups or subgroups they wish to use for aggregating data. So we can use the group by clause, for instance, to aggregate data by day of the week, by client, or by client and by day of the week. So I'll go back over to the customers table. And I'll do, let's see, order date. Drop this down. And then I'll say sum order amount as total order amount. And then I'll group by the order date. If I run this, and then I'll add in an order by order date too, so that it's nice and sequential. Order. Let's see. Select star from orders. Maybe I might have been pulling from the wrong table, but in any case, we can do order date, sum order amount, group by order date, and then order by order date. And that should work now. Yeah, here we go. So now it's given you a nice summary of all the sales that you had on any particular day. You can do the same thing by customer ID, for example. So you can see group by customer ID. You can see who your best customers are, and order by, we'll order by the sum of the order amount as total order amount. And we can do this descending so that you get your best customers first. So you can see customer ID 13 is our big spender who spent $3,300 with us so far. And you could also do it, as I mentioned, by multiple things. So if you wanted to do it by customer ID and order date, you could do that. Group by customer ID, order date, order by some amount descending, and that should work. Once it executes the query. Or if it doesn't want to do that, we might have to refresh this page. So Apologies for the interruption. Get this going again. So select customer ID, order date, sum order amount from the orders table, group by customer ID, order date. Let's see. This likes me now, and now we've got it in there. And you can see it's grouped by both of these columns. And a neat little shorthand for this, which I would not recommend if your queries are being used for any sort of standard reporting or production servers or anything like that. But if you're just exploring data on your own, is instead of writing out the column names, you can just substitute in the column indexes instead. So here, instead of putting in customer ID or order date, you can just say 1, 2, and then order by the third column. We'll say descending. If I run that, it should like that. And yeah, so it spits out something similar. Again, that's useful if you're just exploring data and you want to save yourself some typing. If there are any questions on the on aggregating and how to aggregate things and use the group by clause, please feel free to put them in the Q&A and I will try to answer them. If not, we can move on to the section of the evening on joining data from other database tables. So we've gone through filtering, we've gone through selecting, we've gone through aggregating. One of the next primary selling points of storing your data in databases, as opposed to just doing something like a lot of people do, which is they have multiple CSVs or Excel spreadsheets. The main selling point of databases is that you have the ability to link your data across tables. So SQL has join clauses that allow users to link data based on join conditions. And the joined conditions are usually logical. But you can also join on what are called keys in various tables. So in our schema, for example, we have the orders table. The orders table actually has a key, a link to the customers table. So that customer ID goes back to the customer table. And now you can join those two tables together in a way that makes sense. So the way SQL join clauses are usually structured, we'll just use a generic one for now, is you'll have your first table, table 1, and you want to add a table alias to it. And then you can join in table 2, we'll call T2. We'll say T1.join field is equal to T2.join field. Let me go back and just drop this to a new line. So this is the basic structure of what a join looks like when you type it out. And the reason you want to alias your tables is so that you don't come into the naming conflicts that we talked about earlier. So if you tried to say join field equals join field, your interpreter would yell at you and say, I don't know which join field you're talking about because both tables have a field called join field on them. So again, that's why you're aliasing your tables. So now in terms of the way joins work, there are a few different types of join, and they're each useful for different things. The first join that we'll talk about is what's called an inner join. So let's say you have two tables. You got table 1 and table 2. An inner join will take data that is only common to both of them based on the join condition. So if we wanted to take customers, for example, from our customers table, but we only want information from people who have ordered, who have placed orders, then we could join on our orders table. Drop that to a new line and say on c.id, which is the ID of the customer on the customers table, equals o.customer ID, which is the customer ID on the orders table. And then we'll order by the customer ID. And just like you can put star, you can put c.star, and that will just do all the fields from the customers table. So if I run this now, we will only get people who have ordered things. So what you'll see, if I go down here, we've got 1, 2, 3, 4, 5, 6, 7, and then 9. So customer number 8 hasn't ordered anything, which is why they're not included, because we're doing an inner join. And to go back to our wiki page, we'll go down and there's a animation that I think is a little bit helpful in terms of understanding how this works. So what this is showing you is you've got a table with a city and a country, and then the city name ties to this table over here, which is cities that Godzilla has attacked. So when you're doing an inner join, you'll go through and you'll only take out cities from table A that have been attacked by Godzilla. So you'll see Shanghai was not attacked by Godzilla, so it's not in our final set of data. That's essentially what's going on when you're doing an inner join. Now, if I go back to the SQL fiddle, you'll notice that we've gotten multiple rows for each customer. And that's because of this join condition, CID equals o.customer ID. Each customer can have multiple orders in the orders table, and that will have their customer ID on the row. So every time the customer makes an order, that matches with the ID, and so you'll get that row repeated. So if we wanted to filter this down so that we just had single row for each customer, we could say select distinct customer ID from orders. Do that. And now if we do this, we should get, now we're back down to just one row per customer, because you're doing a select distinct on the orders table first. We've talked about the inner join, which is a way of filtering down your data to a subset. And next, we'll talk about the left join. So a left join takes all the data from the left-hand data, the quote-unquote left-hand table, excuse me, which is the table in your from clause. So in this particular example, if we wanted to do a left join, our left table is this customers table. And then it takes all the data from your right-hand table, which is this one here, wherever the logical condition maps. So we'll switch this to a left join. We'll do our customers table. And let's say we want to do select customer ID, sum order amount from orders. And we'll say group by customer ID. Total order amount, we'll alias this column. So this query here is just aggregating the order amounts by customer ID, and then we're joining it in to the customers table. And so we can say C star, and then we'll say O dot total order amount. Now we'll run that. And now we've got our result set. So we've got everything here is from the customers table. And then we've got the total order amount that we derived from the orders table. And as you go down here, you'll get to ID 8, Kristen Westcar, and they've got a value of null. And that's what's happening on the left join. So if we had done an inner join, this row would not have been there because the customer ID was not in the orders table. But since we're just doing a left join, it's okay for this value to be empty. And so there's another animation here, I think, in terms of how this works. So if you're selecting the city name again from table A here, which is cities and countries, and joining in table B, but you're doing a left join instead of an inner join, this time you will get Shanghai in there, but the Godzilla tax will be null because there's nothing related to Shanghai in table B. So that's how a left join works. Now you can also use a right join, which is basically the exact same thing as a left join except flipped. So you'd be, instead of joining this into that, you'd be joining, you'd be doing the reverse of that. In practice, I don't think I have ever seen a right join used ever in my, I guess, let's say 4 years of working with SQL. It's very rare and not seen a lot. It's almost always you use a left join. So those are the two main types of joins that I wanted to talk about. If you go through documentation, so we can go into Postgres here. Let's go to, might be in queries. Select blah, blah, blah. Expressions. Maybe it's in data manipulation. But okay, I don't know if I'll be able to find it. But in any case, let's see, combining queries. No. In any case, there are a whole bunch of other queries or join types, excuse me, join types that you can use in your various languages. So you'll have exotic things like cross joins, lateral joins, outer joins. They tend to have very specific use cases for what most people need most of the time. Inner joins and left joins are going to get you pretty far. It's pretty rare to see something like a cross join or a lateral join out in the wild. Okay, the query text again. Okay, John's got it, so that's okay. So that's how you join data from various tables together. And it looks like we've got one question. Let's see. Maybe, okay, open. In the left join example, I missed including O dot total order amount on the first line. Does that mean that the join table contained the sum field? It didn't. Yes. So answer live. Done. Yeah. So in nicer SQL editors, for example, you can run. This is technically called a subquery. In nicer SQL editors, you can run subqueries of larger queries. So we could just run this by itself. And when you run this by itself, the result set will have customer ID and total order amount. So if you so it's there to be accessed should you want to use it. If you leave it off, as you noted, it just doesn't show up here. So in this case, since we're interested in it, well, we kind of want to keep it in there, but it's still accessible in your outer query. As long as it's referenced in the subquery here. So I think that answers that question. The last section of our course tonight, and I realize we've gone through a lot. So again, if you have questions, please feel free to post them in the Q&A, and I'll try to get to them. The last thing that we'll talk about tonight are some basic administrative tools. And the first things we'll talk about are the explain and explain analyze keywords. SQL is a declarative programming language. What that means is that in SQL, you tell the database engine or the database management software what you want it to do. The database engine actually figures out how to execute the query under the hood in the background. So here, all I've done is written out what I want. I haven't specified to the database how I want the database to retrieve it. How the database retrieves the data can involve a lot of steps, such as searching, sorting, joining, all sorts of stuff. The how of your query execution is usually referred to as the query plan. The query plan lays out the process your database software will execute in order to return the results of your query. And you can return the query plan by simply adding a prefix to your query of explain. And I won't do it here because this editor has it built in, but that's what it would look like if you were to write this query. What the explain does is it tells you the plan for doing the query. Explain analyze gives you statistics on how the query was actually carried out. So explain you can think of as like the theory of how the database will run your query. The explain analyze is the actual experiment, if you will, of how your query is run. We don't have to do that here because this editor actually has your execution plan. So this lays out how your query is being executed. Now, this is not very useful. So what you might want to do is, let's see, we'll do the explain analyze here, and I'll split something out. Oh, I forgot to use Postgres. No wonder it was yelling at me. So let's see, build schema, run SQL. Or it doesn't like that. So we'll try rebuilding this. Actually, here, copy this. Apologies for the technical difficulties again. Do that. Draw copy. Make sure this is Postgres 9.6. Build the schema. Now let's see. Run this. There you go. Okay, and so this is our, here we go, this is better. This is our query, this is our Postgres SQL query plan for how things get done. And what you can do is you can, there's a nice online tool for Postgres, at least, not for some other ones, that give you some statistics and whatnot and kind of explain it in a little bit of a more easily understood way in terms of what's going on. And like you can see, there's a whole bunch of stuff that's not easy to understand unless you dig into it. So the hash right join, hash aggregate, sequential scan, those sorts of things. But you can get all that data by running explain plans on your query, which is good if you're trying to debug why a particular query is maybe not as performant as it should be. So we got a question. Stop putting the semicolon at the end. Why is that? So it's not relevant to our query executing right now in this editor. If you are doing things that require multiple queries executing, which is typically when you're, for example, updating or inserting or deleting data from your database, you will have to end your query with a semicolon so that the SQL interpreter knows that the query has ended. It's not as important here because you can just hit run SQL and it knows to take your query. But if you're writing something more complicated, you do need to end your queries with a semicolon. So that's a good question. Thank you for asking. So we talked about query plans. The next administrative tool that I just want to make sure people are aware of is the information schema. So sometimes you're dropped into a database environment with no help whatsoever. You just have to figure out what the heck is going on. The information schema can really be a roadmap for you to explore a new database. The information schema is what you might call a metadata schema. In other words, it contains data about your data. It comes pre-baked with most SQL software and contains a lot of useful tables. So you've got the tables table, excuse me, and the columns table, for instance, that tend to be quite handy. So just to show you what those look like, we'll go to the information schema dot tables, add the semicolon, run that. Once it decides to run, there we go. And what this has is information on all the tables in your database. And so you can see we've got our customer table and our orders table in the public schema. And then there's a whole bunch of stuff on those tables. Likewise, you can go to the columns table. And this will say where table name is customers. And so this gives you information on the column structure of the customers table. And you can see the data types, the maximum lengths, so on and so forth. So again, just a good thing to know about in terms of understanding new databases and understanding your data. And with that, we've come to the end of our course tonight. So I want to thank all of you for joining and learning to code SQL. I hope you enjoyed it and you learned something new. In terms of library resources that you can use, the information handout / course syllabus that Sarah emailed you contains a number of links for various library books that you might be interested in checking out to learn more about SQL. Because the library does have a number of books. And believe there's a lot of courses on lynda.com as well, which you should have access to as a patron of the Arlington Public Library. In terms of some resources on the internet that you might want to try out, so we were using SQL Fiddle tonight to play around, and you can try it out with various other languages. And there's also, I think, the SQL Try It editor, which is not quite as nice, but has a wider variety of tables that you can play around with. In terms of SQL dialects, as I mentioned at the beginning, there's a whole bunch of different SQL dialects. that you might either be working with or be interested in learning about. PostgreSQL and MySQL are the two that I've worked with the most. SQLite is a very light SQL database that typically ships with like web applications and those sorts of things. Microsoft SQL Server is pretty popular. Microsoft Access is technically a database. It's not free, but if you have Microsoft Office, you probably have Microsoft Access. And there's a couple other ones that you might be familiar with if you do web development, or maybe not as much if you don't. But these are pretty much the major ones that you might want to be aware of. And in terms of query editors, you don't want to be doing all your data analysis in an environment like this. For one, I think there's a limit on the amount of data that you can put in there, which is why our data set is a little limited. But there are a number of different development environments or graphical user interfaces that you can use for doing SQL. So Squirrel for SQL, for example, is one. You can do MySQL Workbench, which is only for MySQL. I've used this one before. It's very, very adequate. SQL Pro, for example, you can get, although this is Mac only, I believe. And there's a whole bunch of other ones. So if you're curious about programming stuff on your own, those are good things to download and play around with. And with that, I will stop my share and I will give it back to Sarah. And I think we might still have 10 minutes until the course is slated to end. So I think we're ending on time. But I will stay around and answer any questions that come up. So please feel free to post any questions you have to the Q&A and I can try to answer them in the time we have remaining. Thank you.
Thank you so much, Ben, and thank you everyone for your great questions and your engagement. It definitely makes teaching the class easier. So we appreciate it. So if any of you have any questions for Ben, please continue to post them to the Q&A or the chat. And if looks like we got a thank you, so that's nice. We thank you also for staying with us for the whole class. I will send a follow-up email and make sure to relink the resources and send you a link to a class survey. And Ben, it looks like we have a question for you.
What was the difference again between an inner join and a left join? So that's a good question, Susan. So you can think of an inner join as being like you're filtering down the two data sets that you're joining together. So you only want things that are common to the both of them. So in the example we had with the customers and the orders, you only wanted to pull data from the customers table when there were customers in the orders table as well. So you can think of as inner join as being a little bit like a where clause, only instead of writing a where clause, you're joining on another table to get the same sort of filtering capability. A left join is similar, but instead of filtering down to everything that's in common, you keep the items that aren't in common and put null values basically as the stand-in values for them. So if I share my screen again and go back here to the animations. So this, we've got a select city name, Godzilla attacks from A, and the join here is an inner join. You're joining on the city name, so the city name's where it matches there. So Tokyo matches there, New York matches there, Fukuoka matches there, Shanghai doesn't match anywhere. So because this is an inner join, you don't have it in the result set. you're only getting things that are both in this table and in that table, or rather information where the city name is in both this table and that table based on that join condition. For the left join, you don't care if there's something in table A that's not in table B. So here, Shanghai, China still isn't in table B, but it will come out in the results set with just a null for the B city name and the B Godzilla attacks because it's not in table B. You'll just fill in empty values. Does that answer your question, Susan? Okay, yes, thanks. Excellent. Glad to hear it. It's a good question that can be confusing.